All right, so we're doing the final exam review. So for the first question, it says to draw a box plot for the data set. So when we want to do a box plot, the first thing we want to do is get the median. We want to get the middle number. So if we count, we got 1 on each side, we'll get rid of. We got 1 on each side, we'll get rid of. 1 on each side, 1 on each side, 1 on each side. And so we can see that 17 is going to be the median. So now that I have the median, I also need to get my other values. So let's find Q1 and Q3 next. So we're going to uncross those all out. So if I want to get Q1, again, that's like the median of the lower half. So we can just count 1, 2, 1, 2. This is Q1. For Q3, again, we've got 2, 2, so 19 over here. This is Q3. And we also want the min and the max. So the min is going to be 11, and the max is all the way out here at 25. So these are all the points that we need in order to make the dot plot, or make the box plot. So what we're going to do is we're going to take the 11 and the 25, and we're just going to label those on the plot. We're basically making like a number line. So we're going to go all the way from 11 to 25. And then I need to put 13 on my plot. Well, 13 is pretty close to 11, so we'll put 13 over there. I need 19, maybe we'll say 19 is about there. And I'll connect it, I'll make the box. And so the other thing that we need is we need the median. Well, the median is 17. 17 is a little bit closer to 19 than 13. So we can label that as such, and we're done. We don't need to put all of the numbers on the number line. That's just what the box plot looks like. It's got all the key points on it. All right, for number 2, we've got these two equations. F of x is 7x plus 4. That's a linear equation. G of x is negative 4x squared minus 9. That's a quadratic. We have to add f of x plus g of x. So I'm just going to add those down here at the bottom. So 7x plus 4 plus negative 4x squared minus 9. There's not too much like terms to combine. We got minus 9 and 4. I'm going to write it in standard form. So negative 4x squared plus 7x, and then 4 minus 9 is minus 5. All right, so that's minus 5. There we go. So if we look at this equation that we're left with at the end here, this is a quadratic equation because it's got the x squared as the highest exponent. So that automatically makes it quadratic. All quadratics have the same domain. So quadratics are always negative infinity to infinity. But to get the range, it's a little bit different. So I know it's going to open down because it starts with a negative. So I know it looks kind of like a rainbow. So I know that the first part of my range is going to be from negative infinity out to some value. But what that value is that's the y value of the vertex. It doesn't really look like there's a good way to get the vertex using the vertex equation because I need the y coordinate. So I'm going to go ahead and graph this. I'm going to do negative 4x squared plus 7x squared minus 5. Is that correct? Negative 4x squared plus 7x minus 5. Perfect. And I can see it's not even a very good value for the vertex. We get this negative 1.938. Negative sign a little bit bigger, as the top of the parabola, and that's our range. So we're going to go from negative infinity all the way up till negative 1.938, then we're going to go back down. So that's what my range is going to be. Remember, domain is the x's, range is the y's. And again, if we look at the plot, even as I zoom out, I'm never going to get above that one vertex point, and my parabola keeps going out further and further the more I zoom out. So that's going to be it for question 2. All right, for question 3, we have to find the inverse of this function. F of x is 169x squared. Remember, inverse is just the opposite. So if I have f of x is 169x squared, the easiest way to do it is to just switch the x and the y. X equals 169y squared. And then all the operations make sense. So instead of multiplying by 169, if I want to get the y by itself, I'd have to divide by 169 because that's the opposite of multiply. So that makes sense. Instead of squaring something, the opposite of squaring something is taking the square root. So, okay, that makes sense too. So we can square root both sides as well. I can simplify this because the square root of 169 is 13. And that's going to be my inverse function, square root of x over 13. Now, the only reason that this x is greater than 0 part has to be here is because we don't want to put any negative numbers inside here. We could do 0. That's why we have or equal to. But we don't want to put any negatives inside the square root, so that's why that's there. It doesn't actually play a role in the question. It's just part of covering our bases for our answer. For number 4, we've got another system of equations we can solve. So since these are both y equals equations, I may as well just put those next to each other. Negative 2x equals x squared minus 3. I can add 2x to both sides, so 0 equals x squared plus 2x minus 3. And then I can factor this. I can find things that multiply to negative 3 and add up to 2. It turns out if I pick 3 and negative 1, 3 plus negative 1 is in fact 2, so that works out, so that's pretty good. So that means that I can rewrite this one as 0 equals x plus 3 times x minus 1. So to get my two solutions, I use the zero product property, which means I'm just basically making x plus 3 equal to 0 and seeing what I get from that. And I have to do x minus 1 equals 0 and see what I get from that. Now these are both one-step equations, so they're pretty quick. Opposite of plus is minus, opposite of minus is plus. So I have my two x values. But for a system of equations, remember we want to get both an x and a y. So I've got the x value. So to get the y value, I know that y equals negative 2x. Well, if x is negative 3, y is equal to 6. So one of my answers is negative 3, 6. Likewise, if x is 1, y equals negative 2x. So negative 2 times 1 is equal to negative 2. So I get my other answer, 1, negative 2. And those are my two answers. So let me circle those real quick. And it's always good to double check. It's always good to verify. So let's go ahead and graph it, and let's see if we get the same thing from the graph. So we get y equals negative 2x. Okay, that doesn't seem too bad. Y equals x squared minus 3. Okay, so it looks like we're touching at two spots. We've got one up here, negative 3, 6. We found that one. And 1, negative 2. So that matches with what we got algebraically. So we're pretty confident we got the answer right there. All right, for number 5, we have to find the solution to another equation. So again, kind of like the last one, what we want to do is factor. This time, though, it's not just x squared, it's 6x squared. So I need to find things that multiply to negative 24, but add up to negative 10. So this is the challenge here. If we think about it, I want to pick 6 and 4, because I think 6 and 4 is 10, but that won't work, because they would have to be positive 24. So instead, I've got to pick negative 12 and 2, because negative 12 plus 2 is equal to negative 10. So those are the two numbers I have to pick. Since this one starts with a 6 instead of with a 1, I can't just write down the answers. I've got to use either the box method or I've got to use the double GCF method, double distributive property. So 6x squared minus 4. My two blue numbers are minus 12x and 2x. Greatest common factor along the bottom, I can divide those both by 6. Then it's all division. 6x squared divided by 6x is 1x. Negative 12 divided by 6 is negative 2. Negative 4 divided by negative 2 is just regular 2. So looks like I'm going to get, for my equation, 0 equals 6x plus 2, 1x minus 2. But again, like the last problem, I have to solve each of these two equations. So if I solve this one, I get 0 equals 6x plus 2. Subtract 2 on both sides. So negative 2 equals 6x. Divide both sides by 6. And I get negative 1/3 equals x. On the other side, 0 equals 1x minus 2. I can add 2 to both sides. 2 equals x. Well, that one was a little bit shorter. That one was a little bit nicer. Since this one doesn't have any y's in the question, I'm actually done. We just had to figure out what x was. Because y is supposed to be 0. If I were to plug 2 into the equation, I should get 0. And again, like the last one, it's always good to double check. So we got 6x squared minus 10x. X squared minus 10x minus 4. Let's remove the blue one. And my two zeros are at negative 0.333, which is negative 1/3, and 2 comma 0. And that's what we got, 2 and negative 1/3. So that worked out perfectly. So again, we could use the graph to help out if we wanted to. For number 6, it tells us to find the area. So we've got a rectangle. We want to remember that the area of a rectangle is length times width. So that's going to be 8x times 3/4, which is going to be 6x. And that's it. We're done. That's what the area is. It's a little bit weird for an area, but that's what the area is. 7 says create then solve the inequality that describes x. Well, here's the thing. Now we know what the area is, so we can actually plug this all the way back up in this inequality. So 6 is less than or equal to 6x, which is less than or equal to 60. Yep. And we've got a regular triangle inequality from a while ago. So we want to divide everything by 6, because we're trying to get this x in the middle by itself. So 1 is less than or equal to x, which is less than or equal to 10. And now x is by itself, and that's what we've got. So it's a big inequality. You could write it with the word and. X is greater than or equal to 1, and x is less than or equal to 10. But I like this form because that's what it's given to us in the statement of the problem. All right, for 8, we're compounding interest. So it's pretty clear what we've got to do here. We've got to go ahead and just use the compound interest equation. So A is equal to P, 1 plus R over N to the NT power. P is the principal, so P is how much money you start with, so that's going to be 3,000. The 1 never changes, so we'll just put the 1 in the question right here. R is the interest rate. Interest rate is 5%, so we're going to say that that's 0.05, because remember 5 over 100 is 0.05. N is the number of divisions, so we're compounding monthly, so we're going to do 12 divisions. We'll put 12 for both of the N's. And then time is years, which is going to be 10. So at this point, now we throw it into our calculator, and we'll get the answer that we need. So let's get rid of the parabola. 3,000, 1 plus 0.05 over 12 to the 12 times 10th power. We get 4941.03. 4941.03. And so that's how much money Abdul's going to have after 10 years, which is pretty good. So he's making almost $2,000 doing nothing. It does take him 10 years, though. All right, for question 9, we have to find the product. Again, I'm going to multiply this one with the double distributive property, but there is a trick to it. I'm going to explain the trick after we run through everything. Oops, I want to use red. So we got 5x times 5x plus 2. Here we've got minus 2, 5x plus 2. So you can see the 5x plus 2 is shared in both of them. That doesn't change. We're going to distribute. So 5x times 5x is 25x squared. It's really bad squared. And then when we distribute the 5x with the 2, 5x times 2 is 10x. 2 times 5x is minus 10x. Negative 2 times 2 is negative 4. And this is what's kind of cool. We can see that these two things are going to cancel out. So we're just going to be left with 25x squared minus 4. So the trick to this one is if we recognize the form as a minus b times a plus b, that's always going to have the form a squared minus b squared. So it's going to be 5x squared minus 4 squared, or 2 squared. Which again, if we put those in, 5x squared minus 2 squared, well, that's just going to be 25x squared minus 4. But that's a specific trick that has to have this form. If you don't have that form, you can't use the trick, and you have to multiply them out, either with the double distributive property or with the boxes. Pretend we're looking to see how this graph differs. In this case, there's only one difference. Up here, we have x minus 7. So that means we're going to go 7 to the right. So if we're in the parentheses, it's always the opposite of what we would think. So the opposite of, you would think it would go left, but it actually goes right. Remember, when we're at the x, we're at the parentheses. This is always going to describe a right-left motion. So in this case, we're going 7 to the right. If there was a number outside the parentheses that I add, that would move it up and down. For 11, we need to find a perfect square trinomial. So we can use a little nice trick. We can say that 18 divided by 2 is 9. 9 squared is 81, and that's it. We're done. It's 81. If we wanted to double check ourselves, we could. We would write that as x squared plus 18x plus 81, and we'd have to factor it. But we could. It's not too bad, since we know they have to multiply to 81, and they have to add up to 18. We know the whole goal for this, for a perfect square trinomial, is we want the same number. So if I do 9 times 9, 9 plus 9 works. X plus 9, x plus 9. And that does work out. So we do get a perfect square trinomial, because that's the same thing as x plus 9 squared, which is why it's a perfect square. For 12 and 13, we have the two-way table here. So the first thing we want to do is we want to find what percentage of the students in the survey are 11th graders. So we look at, see how many 11th graders we have. 11th graders, we have 24. Total, we've got 50. As a percentage, well, let's turn it into a decimal first. We'll turn it into 0.48, which as a percentage, we multiply that by 100 to get 48%. For number 13, how many grade 12 students prefer action? Remember, we have to add to the totals. So if I want, I can do 35 minus 20, and that should give me my leftover part. That's going to give me 15. And if I want to double check, 15 plus 11 is 26. So that does work also. So the answer is going to be 15. So notice the difference between these two questions. One says what percentage is it? The other question says how many. So how many is a number in the table, and a percentage is going to be out of the whole. So we want to pay close attention to the type of question that's being asked. Percentage, how many? All right, for 14, Luis has saved $100. Each week he saves $10 more than the previous week. Is this linear, quadratic, or exponential? So in this case, since we're doing $10 more, we're adding $10. So that repeated addition is a common difference. So common, that does not show up at all. Common difference. So for the common difference, that means that it has to be linear. And that's what we need for a justification, is that we do have that common difference. In this case, that common difference is 10. It's changing by 10 every time. So if we had an exponential function, this would be a common ratio, would go with an exponential. That's if you multiply or divide. And then for the quadratics, these would be the second differences. So remember, we made those tables where we subtracted everything, then we subtracted all of the subtractions. That's what we would have to check if it were a quadratic. Now you could also say, because it's neither the linear or exponential, it has to be quadratic because it's one of the three. But if you wanted to prove for sure that it was quadratic, that's what you would say. For 15, we have to decide which function will eventually have the greatest value. And this one is kind of like vocab. The whole idea is that the exponential is always going to be the biggest at the end. So I have to figure out which of the functions is the exponential. Well, this one's linear, that one's quadratic. H of x here is the exponential one, which in the picture is the blue one. So we're going to pick h of x. That one's the biggest. 16, we've got a big painting. So the painting without its frame has a width 4 times its height. Okay, so my picture's a little bit weird. It's actually going to be like a really wide painting, but it's okay. My picture is just a little sketch. Then it says that the frame is 3 inches wide along its perimeter. So we got 3 there, 3 there, 3 there, and 3 there. So we've got a nice big frame around it. What's an expression for the area of the framed painting in terms of h? All right, so again, we have to remember, just like in number 6, area is length times width. So if we look at the length, if I were to go all the way across, I'd hit 3, 4h, and 3. If I want to get the width, I'm going to go all the way up and down. 3, and then this h, and then another 3. So I'm going to add those together because they're all in a line. So that's going to give me an area of, well, 4h plus 6 times h plus 6. That did not work out as an h plus 6. So that looks really good because it's almost an intercept form, but I think it'll look nicer in standard form. So we're actually going to multiply these out. So I'm going to multiply them out with the double distributive property. So 4h times h plus 6 plus 6 times h plus 6. I guess that h plus 6 should be black. Let's make that black. All right, and again, we have to distribute. So 4h times h is 4h squared. 4h times 6 is 24h. 6 times h is 6h. And then 6 times 6 is 36. We do have 2 like terms that we can combine. So we'll say 4h squared plus 30h plus 36. And we can stop right there. That looks really good in standard form for the area. It is in terms of h because it has these h's afterwards. Going? We're not going? We're not going. Right, so 17, we have to write the 7th root of 3 using rational exponents. So remember, the 7 is just going to become the denominator of our rational exponent. So when we do that, we're just going to end up with 3 to the 1/7 power, and that's about it. So there's not really much to do with this one, just translating between forms. The next one, we have to solve this equation. So we've got the 1/4 and we've got the 16. So I want those to both end up looking the same. So I think what I'm going to do is try and cast them both in terms of 4. So if I want to rewrite 16, 16 is 4 squared, and I've got x plus 3. 1/4 is 4 to the negative 1, because the 4 is on the bottom of the fraction, and that's still to the x. Now what this allows me to do is I can say a power to a power means I get to multiply. So I can distribute these all to their respective pieces. So I get 4 to the 2x plus 6 equals 4 to the negative x. And now that these two 4's match up, I can cancel those away. So that means that 2x plus 6 is equal to negative x. Well, I'm trying to get the x by itself. This might seem a little weird to subtract not 1x, but 2x. But the number is already by itself, so I may as well move everything away from the number. 6 equals negative 3x. Divide both sides by negative 3. And we get negative 2 equals x. So just like some of them that we graphed, we're going to graph this one just to check it out. So we got 16 to the x plus 3 power. Then we had 1/4 to the x power. Oops. There we go. And we got to find where they intersect. So it looks like they're going to intersect somewhere kind of up. So let's zoom out a little bit, zoom out some more. There's the intersection right there. I get -2. Well, that's exactly what we got. So it looks like we're pretty good. We don't care about the y value because, again, there's no y's in this equation. We just care about the x value. So that's why we get -2. All right, so that works out. 19, write the first 5 terms in a geometric sequence with a of 1 is 5 and r is 3. Remember, a of 1 is going to be the start, and 3 is going to be what you multiply by. So if we start at 5 and do 5 times 3, it's going to be 15, and then we're going to do 15 times 3, which is 45. Then we're going to do 45 times 3, which is 135. Then we're going to do 135 times 3, which is 15,405. And that's it. That's all 5 of our terms. Okay, there we go. So again, the whole idea is to know what each letter represents. For 20, the discriminant of the quadratic equation is 31. How many real solutions does it have? It has 2. The reason it has 2 is because this is a positive number. So since that's a positive number, we're going to get 2 solutions. If it's negative, negative is going to be 0 solutions. If it's 0, we're going to end up with 1 solution. So that's about it. For 21, we need to write a function to model the path of this ball. So it looks like we're using our vertical motion model. So vertical motion model is h of t is equal to -16t squared plus v naught t plus h naught. So if we look to see what we got, h of t is equal to -16t squared plus, if I find my v naught, my initial vertical velocity is 12. T, my h naught, where I'm starting, is going to be 30. And that's my model. So I've plugged the v naught into the equation. I've plugged the h naught into the equation. There we go. To the nearest hundredth, after how long does the ball hit the ground? Because this is a real world problem, probably best to graph it and actually find the 0. So we'll get rid of these. -16. I'm going to put the x in instead of t because Desmos just likes x better. Plus 10x plus 30, was it? Let's double check. Plus 12x plus 30. So again, I'm putting x in instead of the t. And I care about where that hits the ground. So my choices are either going to be the negative value or the positive one. Remember, we're going positive, we're going forward in time, so we want 1.795. So we'll take that one. And we'll just put that one down. Just to show where we got that one, let's go ahead and take a snapshot of that. Again, just to prove, okay, where did we get that? Well, we got that from the 0. Down, over, and we'll say, okay, that's what we did is we found those zeros. All right, so that's blank now. So with number 23 through 25, we just want to use this parabola. I'm going to shrink this a little bit just so I can see the parabola and still answer the questions. All right, I think that'll be good enough. So first thing we want to do is find the vertex of the graphed parabola. So this is just vocab. So we want to find the vertex, which is either the top or the bottom. It's right there. So our vertex is 1.667, comma, -16.333. So that's the vertex. Next, we have to write the parabola in a whole bunch of different forms. So the first form is intercept form. So for intercept form, that's got the form y equals a, x minus p, x minus q. So we get y equals a, x minus, well, my p and my q are going to be the two x-intercepts. So over here is going to be p, that's going to be q. Negative 0.667, that's just negative 2/3. So we're going to switch the sign and make that a 2/3. Q is going to be 4, so I've got x minus 4. So notice again here that all the signs are flipped from the numbers that we have up in the parabola. But again, that fits our theme, because whenever we've got numbers inside the parentheses, it's always the opposite sign of what we would expect. So this looks pretty reasonable so far, but we still have to figure out what a is going to be. Now, in order to figure out a, what we have to do is we're going to have to actually plug in another point. This is a very convenient point to plug in for x and y. So this is going to be the x, and that's going to be the y. So I'm going to get negative 8 equals a, 0 plus 2/3, 0 minus 4. Well, that means that negative 8 equals a times 2/3 times negative 4. Okay, looks like I might need a little bit more space than I've got here. That's all right, though. So if I do this, if I divide this by 2/3 and by negative 4, and you might think it's weird that I'm doing this in this step and not actually finding out what 2/3 times negative 4 is, but I want to do that because mentally it's going to be easy, because negative 8 and this 2 and this negative 4 would all cancel, and 1 over 1/3 is just going to give us 3 for a. So that's what we'll get if we plug that into a calculator. So now that I know a, I'm ready to answer the question. So the final answer is going to be y equals 3, x plus 2/3, x minus 4. And we got to think, does 3 make sense? Well, 3 would mean that it opens up, because it's a positive number. Does that open up? Yeah, it does. And that's about enough of a check that I want for right now. I feel like that's going to be good enough to say, okay, I didn't get a negative number, so I kind of feel like I did the right thing. So for the next part, we have to get standard form. To get standard form, we're going to multiply this out. That's all we have to do to get from intercept form to standard form. Well, that doesn't seem too bad. Again, I'm going to take x and multiply that by this x minus 4. I'm going to take 2/3 and also multiply it by the x minus 4. Now out front, we still have this 3. So that 3 is still looming. That 3 is still out on the outside. We didn't forget about it. We just don't want to deal with it yet, because we want to distribute first. So we get x squared minus 4x plus 2/3 x minus, well, 4 times 2/3 is 8/3. Okay, I mean, we still have this 3 that's out here. And now I got a decision to make. I can either combine my like terms now, or it looks like it's going to be easier if I distribute this 3 right now. And the reason it looks like it's easier is it's going to cancel these 3's out, and we're going to get rid of the fractions. So we're going to end up with 3x squared minus 12x plus 2x minus 8. And now I can combine my like terms. 3x squared minus 10x minus 8. And that's actually not too bad of an equation. Okay. Let's do vertex form. So vertex form is the last form. For vertex form, its form is y equals a x minus h squared plus k. Well, I know h and k because that's the vertex. H is here, k is there. So y equals x minus 1.667 squared minus 16.333. Because, again, this minus sign comes in here, so it'll become negative. And inside the parentheses with the h, it's the opposite. So we just need to get a, but we have to remember a is the exact same. A was 3 here, a is still 3 here, a is still 3 in vertex form. So it turns out this one's actually pretty quick to do once you've actually figured out what a is. So we figured it out in all 3 forms. Now we want to double check. So let's actually graph them all and see if we got the right answer. So let's get rid of this parabola. 3x plus 2/3 x minus 4. Like the one that I had, x plus 2/3 x minus 4. Let's go home and let's see. I guess we got to zoom out once. Maybe we got to zoom out again. But do we have all the right numbers? -667, 4, -8, 1.667, -16.33. I think that's it. I think that's our parabola. That looks pretty good. That's exactly what we want. Now I'm going to check the next one. 3x squared minus 10x minus 8. And that exactly overlapped it. So I don't even need to go back and double check. I can already tell because it completely overlapped it that that's exactly what I want. Last one, 3x minus 1.667 squared minus 16.333. So it looks like it's a little bit off from the other ones, but again, I think that's mainly due to rounding. That looks pretty close. I'm pretty happy with that one too. So I'm going to stick with that. I'm going to say those are the answers, and I'm going to be happy to move on to the last question. Last question just asks how many real solutions does the parabola have? So the trick here is actually finding the x-axis. So in this case, the x-axis is right here, and we have to find out how many solutions we have. We've got 1, we've got 2. So it doesn't ask for what they are, it just asks for how many. So we just got to be careful again when we're reading the question, because the answer is 2. There are 2 of them. And that's it. That's the entire review guide.